some quality improvement tools. When we try to control quality and we determine that the process capability is insufficient, or we determine that maybe we had a process in control, but now it went out of control and we have some unusual variability, we might want to look for causes of problems, right? In both of those cases, of quality problems. And we use several types of tools. One of those tools is Pareto chart. A Pareto chart is something that is used for studying causes of defects. So, for example, if we have a too large number of defects in some product or service that we deliver, and we want to find out the causes of those defects, if we study them, right? I mean, of course, it requires some extensive studies, and then once we find out for all the defects that we studied, what was the actual cause behind that defect, then it's a good idea to use Pareto chart to determine which of those problems or causes are actually more frequent and which are less. It's actually quite a simple chart. All it does is it takes all the causes and then sorts them from the largest frequency cause to the lowest frequency cause. So, I mean, in a table, you will have it like this, right? This is some website error, browser error, order number of out of sequence, or product shipped, but credit card not billed or something. You know, these are some causes of defects that were determined for some problematic situations. The total was 110, and these are sorted, you see, from the largest frequency to the smallest. This is the percentage is calculated, and the cumulative percentage is calculated. And what the Pareto chart is supposed to show is present this data visually. Bars are for the number of occurrences that are on the left axis, and this line is for cumulative percentage of occurrences, which is represented on the right axis. And what is nice about these charts is that, first of all, they focus our attention on the types of or causes of defects that are more frequent. So we start reading from left to right, and we see browser error was the most frequent, or order number out of sequence was the second most frequent cause. But also, what this line shows us is that it helps us, see how large the percentage so far with the first two defects. What's the percentage in total? We see is like 65% of all causes are the first two defects, or 80% of all causes are the first three defects. And so these kind of charts, first of all, are useful as a presentation tool to help us focus on the most frequent causes and help us also focus the work on reducing the number of defects by the largest possible amount, right? If, for example, we can eliminate the browser error, maybe there is a simple fix we can do. We will already eliminate almost 40% of defects. So it's much better to work on that than maybe on the least frequent root cause of defects, right? So this is Pareto chart, a presentation tool, helps us focus on the most frequent causes of defects, and it also helps us see the percentage of causes that the most frequent 1, 2, 3, and so on causes constitute. Another tool useful for determining quality problems or working on quality problems, especially in groups, is fishbone diagram. A fishbone diagram is a nice tool because it helps a group of people, for example, brainstorming to find the root cause of a problem. It helps create a common map for all possible causes. So suppose this is created for steer support height that deviates from specification. What could be the cause? And there are the common the 3M: machines, men, or materials. Nowadays, more often, man is replaced by people, right? And then there are some additional causes. So you see, typically the error in manufacturing can be caused by a malfunctioning machine or malfunctioning or faulty material, or maybe some error that people make, or some other types. And you see, this is called fishbone because it looks like the bones of a fish. And notice that what happens here is that each of those causes can be divided into sub causes. For example, here material, what could be the problem? Material is too soft, or maybe there are other types of causes that are also because of the material. And the same thing, machine, why is the machine malfunctioning? Again, we can put on the map what are the possible ways the machine may be malfunctioning, and so on. As I said, this is an interesting tool because it helps a group understand and share knowledge, and perhaps give each other ideas on what actually may be causing the problem that we're working on. There are many other quality improvement tools, but these are just two examples.